So I noticed. You can see the contrails on there too. Aren't they beautiful? See the contrails?
These two going front and center.
We never saw those. There's supposed to be ice eddies coming down the coast.
Yeah, I
see the ice eddies?
Some people live.
Yeah.
All right, thank you everybody for coming to the last weather briefing of the semester. As is tradition, we have Rich Grumm do the last. So we'll see him again in August, but until then, we have Rich with semester-ending weather.
It's very dire stuff. So that's So we'll look at some of the interesting weather that occurred over the past semester, so to speak, in some of the events that impacted us all. It was clearly a February to remember. It would be nice if it was a December to remember, but the alliteration wasn't quite there. We'll talk a little bit about the March Madness, and for the 16th time, how goes it? How goes art? Look at the Gozar. Oh, while I was sitting here, I noticed they had a Gozar image here over Newfoundland, and you can see the contrails and the ice eddies and stuff that, geostationary orbiting satellites we've never seen before. We'll talk a little bit about uncertainty, and then our brief warm-up we'll talk about the graduation weekend, which is just about a week and a half away. So the weather from January to April, we all had our favorite events. Most people probably were biased around the 13th or 14th of March, so anyway, I bicycled most of February. I really like February actually. But we had the low cloud and fog event of the 21 and 22 January event. Some of us were a little bit late getting to Seattle. I don't know if anybody in the room was affected by that event. So instead of flying to Seattle on Saturday, I took a 22-mile bike ride in the fog. But it ended. That event actually ended with a wet snow event on the 23rd. A wet, sleety, ugly snow. I know, some people had to drive home from Tussey in the sleet. You have to ski with the kids on the mountain there. And February kind of gave us all a warm feeling, if you were here. And then we marched back into winter, and in March, most of us began to at least see the GOES 16 goes on. I guess at some point we're just going to call it GOES 16, right? So the February warmth, several Pennsylvania ski areas actually closed down because they lost their snow and they couldn't make snow. I think that may have been more of a business decision than a meteorological decision. Most of the U.S. set many record high temperatures several days during the month. State College broke 70 twice in that month. Which is 70 is kind of rare in February here, but twice is truly unique. And many locations have the warmest February on record in the eastern United States. So this is a list we went through when they were closing, but this is a list of the ski resorts that remained open through it all. And you can see the 4 that closed, and Tussey was one of them. And it was the first time that the State College area school system did not complete its intramural ski program. So we didn't get to ski. We missed one day. And this just shows the records that were set, the ties and the records broken cumulatively across the 28 days of February. You see, it was quite an impressive amount of high temperature records that were set during the month of February.
Is that just for Pennsylvania, or was that?
No, that's the whole U.S. I just saw the NC ice type.
Oh, I didn't see the numbers.
If anybody in the room knows how to go to that site and get the daily numbers, I have to query them all and then I have a Python program that parses them all out. So it's problematic to get these data, but thank goodness for Python, because you can get really wrapped up in stuff. So anyway, this just kind of shows you how warm it was across the United States. Snake jokes. So it just shows how really warm it was. And we were kind of close to the epicenter of warmth during February 2017. It was a really warm month. So this shows the 850 temperatures during the period of maximum heat. And 850 temperatures were peaking out down here 16 to 18. This is actually 2 meter temperatures in this case, actually 16, 18 Celsius at the surface. But clearly the GFS was too cold and all this stuff, and so was the HERT. And if anybody uses a 2 meter temperature for the GFS, on a sunny day it's got really, really bad cold temps. So this shows the pattern during the hottest part of the month. You can see our heights. We had a 576 contour coming from our part of the state, and the heights were above normal, and we had 2.5 standard deviation above normal ridge came over our area. So it was a really interesting month. But you can see on the 0 to the 25th, there was this blue zone. There was a abnormally strong shortwave actually coming through the Central United States that was going to end, the heat event was going to end. And that led to a tornado event. We had 2 tornadoes in the state of Pennsylvania, one down in Lancaster County and one up outside of Scranton. And if you look carefully, there's a red dot first ever tornado in the state of Massachusetts was reported that day. And this is the second year in a row that we've had February tornadoes in Pennsylvania, and both of them have been in Lancaster County. So this just kind of shows the storm that was down in the Scranton area, New York area. You can see the rotation coupled down here. You can see a little bit of a hook in the reflectivity data. It was okay, but this was the storm that went by DuPont. And you can see, I kind of zoomed in here using GRT. You can see a little bit of a pendant echo and stuff, but the velocity data screams out at you. And this was an EF2 tornado that went just past DuPont and Mountaintop. I made a loop of this, but I shipped this PowerPoint. I didn't want it to eat up. If I get about, was it 10 megabytes, the government won't send your email. You know? Yeah, so, anyway, you can see great couplet, nice rotation couplet. Kind of, that's pretty impressive for February, I'd say. So we saw something not quite as impressive just last week. And then it got cold. And then we had this March snow event. This kind of shows an analysis of the snow. And then this shows an analysis of the precipitation. And you see the gray zone. It's not one of my hairs that fell onto the map. That actually is over 3 inches of liquid equivalent precipitation that fell near Binghamton, New York. And you've heard a lot of things about this snowstorm, how they overforecast the snow in New York City along the coast. And that was a precipitation type issue, which we'll get to. But really, the models missed the amount of precipitation that actually fell in the southwestern and western Catskill areas and parts of the Mohawk Valley. They were off by almost a factor of 2 at times with the QPF that actually verified. So the 30 to 45-inch snowfall amounts were real, and they had a lot of water in them. And fortunately, this thing had a nice little comma head and came back, and we got some snow back here. So we had a respectable snow and about 7 days of cross-country skiing in March. Could have always skied in February and cross-country skied in March, but to be better. So this just kind of shows the evolution of the snowstorm. You can see this. I don't know if it shows up there, but these kind of these grays and then these greens showing these 6 sigma 850 U wind anomalies, and we had this really strong U wind anomaly, which we kind of know is one of the tip-offs for these kind of climatologically and meteorologically significant winter storms. And this storm fit the bill. Just that if you lived in the coastal zones, it wasn't as good. So this is a predictability horizon diagram, and this is Seth here. Seth Saslow made this image. But we wrote a paper, Dr. Graybush was the lead author, about predictability. We use these predictability horizons so you can see all the different forecasts from every model run. And just, the top shows how many hours prior to the event, and then the red line shows the mean QPF in this case, and then it shows the dash line shows like one standard deviation around it, the mean, and then you can see all the dots show each individual members of the GEFS's forecast. And you can see it started to hint of a really big QPF event at about 90 to 84 hours out. So people had a big confidence in a big snowstorm or a big precipitation event. And then the models kind of honed in on this like 40 to 60 inch QPF event with very small spread. And then it actually went up closer to the event time. And this was, you know, the only pH diagram I've ever seen better than this was Mammoth Springs, where it actually did this for 168 hours. But in out west, the mountains, you have fixed forcing. It's pretty hard to miss where it's going to rain. So it looked pretty good from a QPF point of view, but then this shows the same diagram, except we've changed the scale a little bit, and they're colorized by the precipitation type. And you see everybody on Saturday, this was Friday night, and Saturday, everybody was getting optimistic of this big snowstorm on Long Island with, you know, 40 to 60 inches of liquid equivalent falling of snow. And then on Monday, you start to see these yellow and orange dots showing freezing rain and sleet. And as the event neared, it ended up being primarily a sleet. These dots are colorized by the dominant precipitation type. So we had a good handle on the QPF, but we had a really bad handle on the precipitation type, where a mesoscale boundary kind of took over and dictated what happens. So I think this is a good argument why we really need high-resolution mesoscale models when we get in the Weather Service lingo. When we get into the warning mode, we really need to account for these mesoscale boundaries that can really mess up a forecast, especially in a kind of global model like this. It really shows how where the uncertainty was not the QPF as much as the precipitation type. And this just shows over time. This is the HER, and it kind of shows where it was snowing, where it was sleet and freezing raining, and where it was. And you can see in time that sleet, freezing rain came right across Long Island and kind of settled in over the bottom panel over New York City, where they had a lot of sleet. And I guess they had like 6 inches, 7 inches of snow, but a big chunk of it was sleet. So, and this was a GOES-R. GOES-R was active during the event. And this is just one of many channels that we made loops of. I just included one. And you can see this is the low-level water vapor channel. You can really see the intense drying. You can see the different dry slots and this elongated band that's set up and just rotated and pivoted over the Catskills. So they had a really impressive snow event. So this is, I think, the first major storm we had in our office, and the availability of GOES-R. So GOES-R was on the job, and I guess we're supposed to call it GOES 16. And I don't know when you're going to be able to display it here officially. Did they give you a date?
It's not supposed to be operational right until like November.
Is that true now?
A year after its original launch date.
Well, it's never good to be late for launch. I mean lunch.
Right.
So, and then we had a tornado event just last week, and this kind of shows the Youngsville area tornado. And you can see the meso-circulation of the storm right about here. You can see the really good inbound winds. This is the SRM down here, nice mesocyclone that went through the Youngsville area. I guess this last Thursday. And then more recently we had this big rain event overnight in the Carolinas. The complex upper level low, maybe a subtropical wave that kind of moved into it. You can see some of the rainfall estimates down here. I guess I've heard reports of 6 to 8 inches of rain overnight. So, and that brings us back to predictability. And this shows us how this diagram goes out to 210 hours. And the GEFS really didn't begin to catch on to this thing with much more than about 24 to 30 hours worth of lead time. And if you look at the mean QPF, it's about 55, 60 millimeters. So we're looking at a 2-inch rainfall event with a range of 2 to about 3 inches of rain. The area in Raleigh area had some places had almost 8 inches already. So this was a real low predictability case, probably because it's an upper level low, a lot of convection, and then this kind of mesoscale feature that if you look at the long range satellite loops kind of interacted with the whole system. So the weather's been kind of fun, and one thing we can be pretty certain about, there's always going to be uncertainty. And I guess that comes with being a live creature. So now we'll look at the coming weather. We have the lifting low that's given us the drizzle and the spotty rain, and we'll get rid of it in the next 24 to 36 hours. I think we're mostly rid of it by tomorrow morning. So to me, it's to ride or not to ride, because we have a ride scheduled at 5:30 tonight. I guess the rain is light enough that the diehards will be there. So and then we have the beginning of the Wednesday warm-up. And does it actually heat up on Thursday? That is the question. Anybody forecast? I guess anybody forecast must be considering how it could be pretty toasty on Wednesday. So, but as I was talking to Paul earlier, it's kind of an ugly or dirty warm-up, and so we'll know how hot it gets on Thursday or Friday. I guarantee you that. So, and then one of the issues we have, we're going to be on the western edge of the subtropical ridge, so we'll be warm, but we're also going to have above normal precipitable water values, which means it'll be unstable, part of it cloudy, and that'll increase the chance for sporadic showers and thunderstorms. And then a trough, it begins to build back into the eastern United States next week, so that'll kind of cool things down. And some of the long-range guidance wants to build a ridge well to our west. So, but right now, it's forecast in the NAIFS and in the GFSBC. Graduation weekend looks really normal. So the cutoff flow is almost gone. This is an image valid from the 6Z GFS, and you can see a little dot right there. But you see, once that little cutoff goes, we're really basically in a ridge. And then down below, you can see, we're in a cool pocket a little where the air is about normal, but to our west and to our northeast, it's above normally warm. It's like at least 1 standard deviation above normal. That's a 16 °C isotherm right here, coming up into the middle Mississippi Valley. And then this forecast is valid on Thursday afternoon, and we got like a 576 contour over us. I can't find the mouse. Do you see the mouse on there?
Yes.
And our heights are above normal, and the GEFS, this is GFS biospheric data, in fact, says we're like 2.5 standard deviations above normal Thursday afternoon, with 850 temperatures almost over the entire state over 16 Celsius. So if that were to verify, it would be a pretty toasty day if we had close to full sun. And then we have 18Z Monday. We see this nice blue trough coming through, and the ridge is now offshore. And then, and our 850 temperature is still above normal. We're going to have 850 temperatures above normal probably from Wednesday evening all the way probably until at least Sunday afternoon or Monday. And then we should begin to chill down. Our heights, we get to a weak trough, and our 850 temperatures cool down to about 6. That's about a 10 °C drop. So it should be noticeably more comfortable next week. And then this just shows graduation weekend. We're about 7 to 8 at 850, which is pretty darn normal. Our 500 heights are around 568, 570, which is absolutely normal. We're in northwest flow, so unless there's a hidden shortwave, right now is forecast. It looks pretty good, but that'll change. So, and I think we can now look at some real data, which that was real data, just a little older. So this image here, I don't know if you can see how well it shows up. This was a nice image. We look at the GOES-R data about a week or two ago, and it was interesting to see all the contrails coming out of across Georgia. This was on when the meso sector was over the southeast, and you can see the fog in the valleys that was trapped in North Carolina, the mountains of North Carolina, Tennessee. And I don't think this loop is actually fast and long enough, but it was amazing to watch the north central Tennessee fog and low clouds evaporate that day. It was pretty interesting. So this loop, unfortunately, is a little too slow for the number of images that when you have 1 minute data, you really got to do fast loop speeds. So this was another nice image, and I think the fast one's better. But the key feature is it was a mesoscale convective complex that put down an outflow boundary, and you could actually see the cold air as it went across Kansas and Nebraska, and it actually kept firing off new convection, and eventually it got all the way into the state of Illinois. But if I loop this in the fast mode, you start your tension up here in the beginning of the loop, you could actually see the gray colors and the cold air just zip across, and it was like, and just new convection forming on the southwest flank as the thing moved across was pretty impressive. So I believe this is a 5 minute data. So it's interesting to get used to watching 1 minute data. We have to learn how to use our time parameters on our AWS better, because if you want to see things historically, 60 images an hour is a lot of data. And if we ever go into the full mesosector over, so we get the timing right on AWS, it's 30-second data when the mesosectors are overlapped. I don't know if anybody did. 30-second data is a lot of data. I mean, our radar, with the lower sweep, we get about every 2 minutes. This is every minute, and then we can have every 30 seconds, which we haven't ironed that out yet in the weather service, how we're going to actually do that, at least not on our AWS yet. And I don't think the 12Z GEFS is in, so it's tragic. So, but we'll look at the GEFS from 6Z. That'll do the job for us, roughly, and to see the large-scale pattern. And we live in the Eastern United States, so that'll do. So I guess we'll start out with, actually we'll go with the high-resolution data. When's it going to rain? We'll use a temp. So this was this morning, and this morning had the rain coming up into western Pennsylvania, and then you can see this afternoon it had some rain coming into the southeast and going up into New York State. And we were kind of on it. We're looking at a 1/10 of an inch of QPF, probably a 1/10 inch of QPF in these 3-hour windows. And it's really kind of low for us. We're on the edge of any precipitation. Of course, this is a global model, and it kind of focuses all the precipitation off to our east. And then we don't see anything until potentially that front to the west maybe triggers some showers and thunderstorms late Thursday into Thursday evening. So that's that front to the west. So, and it looks like this model just shows popcorny kind of low probability of low-end pops into the weekend. We're on the edge of a big ridge, and and our physical water is pretty high. I'll show the physical water values and see we're pretty moist throughout. Once we get rid of this F11, right? If I go forward, and you can see that any time we're in yellow, it means our physical water is above normal. 1 standard deviation is yellow, and 2 is the darker yellow. And you see our physical water is above normal, and it stays above normal for Wednesday. We begin to dry out a little bit on Wednesday, but not too much. And then the moisture comes back on Thursday with that front to the west. And so we're going to be pretty moist, and you can see clearly a warm tongue comes across on Friday, which will probably give us a chance of showers, at least probably 30 to 50% chance of rain. And we don't really dry out long term until Sunday, Monday. So it's not a great pattern if you want to do a lot of things outdoors. You have to be worried about it could rain. And we can look at the 850 temperatures over our region, and you can see that our 850 temperatures go above normal, and they stay there. It looks like Thursday morning it's like 16 to 18 degrees. Pittsburgh probably going to, if this verifies, Pittsburgh could probably push 90 degrees on Thursday before the showers get there. But we're 16, 17 here on Thursday after this. It could be warmer if we're sunny. I know a lot of the 2 meter temperature guidance and WASP guidance is like low 80s figure, but my guess is that might be low. So that's how the weather looks. Kind of reinforces what I said. I wish we had the 12Z data. So the short-term forecast, of course, we can use something that's more relevant. We can look at the HER. We can start out with the evolution of the radar. And you can see the showers that were earlier up in northwest Pennsylvania, and then the stuff to our south. And you can see the more intense echoes, if you will, that the Hercules kind of stay in New Jersey and New York, although some of the stuff kind of leaks up in our area, but most of the stuff is like in the 20 or less dB range in the model forecast, so it's not really impressive for us. And you can see by about 3Z, it kind of dries it out, and then we'll probably have a dry period, I'm going to guess, from sometime around midnight tonight, so probably Thursday afternoon, evening, maybe. But if we look at the instantaneous precipitation, because the radar doesn't necessarily mean it's the model thinks it's generating QPF. It has some bumpy stuff around here, just really isolated, around 18, 19Z, but it keeps the real accumulating rain pretty much to our east, where the inflow is the best. So if you use these mesoscale models, it looks like, you know, we could get some light rain, but the real juicy stuff's to our west. But of course, I'm putting my feet in the pedals. At about 5:30, you can see that that's right around the highest threat of rain comes in just after that. So there's a lot of uncertainty. It looks like, you know, you can't rule out some light showers here, but nothing of note. It looks like our next best chance of rain is going to be probably Thursday night into Friday, and then showers. And graduation, the weather will change, so we'll know on the 6th of May. We'll know. Any questions? Oh, before I do that, I can wrap this up. I have a summary. So, semester dire weather. I went back to the beginning. I feel like I'm in the Princess Bride. So basically, you know, we had some real interesting weather, historical weather, I think, of note, especially February. And we fortunately got some March snow, and I won my 15 over and under bet with Trump. Told it was 25 over and under, and I got a free Chinese lunch out of the deal. So, but uncertainty will always be with us whenever you, especially if you're graduating. Remember that, you know, you have to master the probability as you forecast forward in the rest of your life. And weather-wise, locally, we have these lingering showers and drizzle to worry about, probably till before midnight, and then warmer Wednesday and Thursday. It's not going to be a really pretty warm up, and we'll probably cool down or dry out sometime in the Sunday, Monday time frame. And the graduation weather it'll be what it'll be. Que sera, sera. Any questions or comments? Or speechless in Seattle.
Nothing for Rich? Not about the weather? Any questions? All right. Thank you, Rich.
Thank you.
Thank you, Rich.
Hey, Bill, can I email Bob about the temperature?
Oh, yeah.
Okay.
Yeah, thank you.